Welcome to June 15th LeetCode Challenge, longest string chain. You're given an array of words where each word consists of a lower English letter. Word sub A is a predecessor of word sub B if and only if we can insert exactly one letter anywhere in word sub A without changing the order of the other characters to make it equal to word sub B. For example, you have ABC is predecessor of ABAC, while CBA is not predecessor of CBAD, BCAD. So a word chain is a sequence of words, word 1, 2, 3, 4, all the way up to K, with K greater than or equal to 1, where word at 1, word sub 1 is a predecessor of word sub 2, which is word sub 2 is a predecessor of word sub 3, and so on. So a single word is trivially a word chain where K is equal to 1. Return the length of the longest possible word chain with words chosen from the given word list. So say we're given this word chain here, the words, right? The array of words here. We want to find the longest word chain. So the longest word chain would be basically 4, where it includes A, BA, BDA, and BDCA. So basically, to progress from one word chain to one word node to the next word node, you basically have to add one letter to it. And that's pretty much how it goes. And the longest word chain, for example, number 2 here, is 5, because we go basically from XB to XBC, which is the first one, and then it goes to this one, and then it goes to this one, and then this one, right? Pretty much adding one letter onto the next letter each time, or adding one character into the word chain each time. Example 3, the longest word chain is 1, because there's no way of adding one letter from A, B, C, D to get this letter, to get this word chain here, because it's trivial. The trivial word chain is just one of them. So the length of words is between 1 to 1,000, and the length of each word itself is between 1 to 16 characters. Word index I consists of only lower English letters. So to solve this, there's so the first thing we want to come up with is obviously we want to keep track of the word chain, the longest possible word chain. So ideally, we will use a dynamic programming approach for this. So the questions are, it's asking for the longest possible word chain. So it's an optimization problem, right? Got that out of the way. The chain extended by adding a new word, which only depends on the last word of the chain. So it could be broken down to sub-problems. So basically, if you have the longest word, you can always break it down. If you can find move one character and get another word chain in the node in the word chain, then you would successfully have a length of output of n plus 1, right? So generally, let's kind of use a bottom-up approach for dynamic programming. Generally, we think of a recursive relation in a dynamic programming problem, and optimize it. But it's not really required in this one. So let's just jump right into it and develop a dynamic programming set here. And we are going to basically have an output, call size 1 for now. So for word in, so we want to sort the word, sort a word, and we want to sort it by the length, so it'll be key length. So we're sorting basically the word by smallest to biggest in terms of length, and then we update our dynamic programming array at the index word to be 1. So each word itself has a word chain of 1, and then we just want to basically build up upon that. So let's say for index I in the range of the length of the word, if we can basically we need to develop a previous variable, so priv. So update that with the word slice, I should say, between the beginning to the index I plus the word at I plus 1 to the n. So we want to basically update that variable, basically the word from the beginning of I to the end of I, and then concatenate those together. So when we do that, if the previous is in our dynamic programming set, then what we could do is we could do two things. We know that we could update the dynamic programming word in the index to be dynamic programming index previous plus 1. So we know that the count increases by 1 because we're able to make basically make a previous word within our dynamic programming array. That means that the word is a processor of our longest word, and then so we increment that by 1. We also want to increment our output by taking the maximum number of all the output we have so far and the dynamic programming at the word. This is the dynamic programming at the next word. This is where we keep track of the processor this specific word has at that point in time. And then after all this, we just want to return our output. And this should ideally work. Alright, submit it. So let's take a look at the runtime complexity of this. So we know that time complexity wise, we have big O n log n for the sorting algorithm. We know that we have big 2n for the, basically we have a loop here, for loop, another for loop. So it's big O n log n plus 2n, but that should work enough. Space complexity is big O of n for sorting of this dictionary, and also the dictionary as well, and the space created for previous using this n times, so big O of n. Alright, that is all. This is longest string chain. I mean, once you determine that's a dynamic programming and optimization question, it becomes pretty straightforward, but it's still quite a difficult question. Alright, have a great day, guys.